Hi everyone. Okay, this question says that the line px plus qy plus 14 equals 0 passes through, and they give us 2 points, and we're supposed to use the 2 points to figure out what the constants are, p and q. Okay, now, we've done something similar to this in the past here. This one's a little bit different because the two unknowns come in one equation, and we're only given the one equation here. Okay, but when I give you the point, for example, when I give you the points negative 3, 1, negative 4, 6, remember that what I'm giving you are x and y values. Okay, x and y values. So what I can do here, by plugging in that first one, I'm going to get p times negative 3 plus q times 1 plus 14 is equal to 0. And I can simplify this a little bit for myself because I'm a little bit lazy and I like when it looks a little cleaner. And there we go. So that information here allows us to write negative 3p plus q plus 14 equals 0. The next point, if I plug it in, so this is equation 1. The next point, if I plug it in, is going to give me a different equation because it's got a different point in there. That'll be p times negative 4 plus q times 6 plus 14 equals 0. And again, I'll clean this up a little bit. So negative 4p plus 6q plus 14 equals 0. And I'm going to clean this one up even a little bit more than that because notice that everything here is divisible by 2. Okay, so I'll just divide everything through by 2 here, and that'll get us negative 2p plus 3q plus 7 is equal to 0. Okay, now, here are my two equations. Here's my system. So maybe I'll go over here and rewrite the system. So negative 3p plus q plus 14 equals 0. And I've got negative 2p plus 3q plus 7 is equal to 0. Okay, so this is now the system that I want to solve. So now what I got to do is I just got to choose a method. Do I want to do elimination or substitution? Okay, now I think most people, and this isn't necessarily true, but I think most people prefer to do elimination here. So what I'll do here is, for example, I'll eliminate the q variable because that's an easy one to do. All I got to do is multiply the first equation through by 3. So if I multiply the first equation through by 3, I'm going to get negative 9p plus 3q plus 42 is equal to 0. And the second equation didn't need to change. Negative 2p plus 3q plus 7 is equal to 0. Because the coefficients of the q's are the same, when I subtract, okay, I will get rid of those. So but this becomes negative 9p minus negative 2p is going to give me negative 7p. Okay, just watch that. Okay, we've seen this before here, and it's the subtracting the negative is really what causes problems here. 3q minus 3q goes away. 42 minus 7, okay, is going to be 35. And now we could do this a couple of different ways. You could bring the 35 over to get negative 35, but when you divide by negative 7, p is going to be 5. Okay, so now I know what p is. Great. Now I'm going to take and plug that back into one of the original equations. I don't know, maybe I'll do it into the first equation because when I look for q, I don't have to divide by anything. So if I plug that into the first equation, I'm going to get, okay, negative 3 times 5 plus q plus 14 is equal to 0. So that's negative 15 plus q plus 14 equals 0. And negative 15 and 14 is going to give me negative 1. So q is equal to 1. And so the point, well, actually, in a case like this, you don't really answer it as a point because we don't really know what order these should come in. I mean, you could argue that alphabetical order, okay, but this is kind of like a word problem here. We're just solving for the constants, and as soon as I identify that p is equal to 5, q is equal to 1, okay, in problems like this, that's enough. That's sufficient.